Well, good afternoon, everybody. Thank you for attending this Pavinar session, which will cover the basic Portland cement concrete maintenance principles. To start out, if you cannot hear me talking right now, there are two options. You can check your computer volume and/or the speakers, and you can also look in the Illuminate software, which is what we're watching this webinar through, going to Tools, Audio Setup Wizard, and follow the instructions for help. Beyond that, I'm afraid I cannot be that much of a help. Everyone's computer is configured differently and such, but these steps seems to have worked in the past. Now, I also ask that if you have a question during the Pavinar, please do feel free to raise your hand. If you look on the upper left-hand side of the screen, you can see a list of participants. And at the bottom of that list, there's a little hand with a green arrow. And if everyone could click on that hand with the green arrow to indicate that you can hear me, and you can also see the little arrow. There we go. If you have a question during the presentation, please feel free to click on that hand, and then I will know that you have a question, and at an appropriate time, I will pause. Now, I've purposely muted everyone's microphone because a lot of times during these webinars, a lot of background noise is created. So unfortunately, no one will be able to talk. But if you do have a question, please feel free to raise your hand, and then you can type the question into the chat box, which is below the list of participants. So you simply type your question in there and then hit the send button, and everyone will be able to see the question. After the presentation, I will email out professional development hours to each of you in the form of a certificate. So the email that you used to log in will be used for that. Yes, Dean, did you have a question? I'm sorry, Dean, did you have a question? You may be typing, and I don't mean to rush you. Okay, well, if you do have a question, please do raise your hand and we can progress from there. So as I mentioned, today we'll be talking about basic Portland cement concrete maintenance principles. My name is Dr. Andrew Bram. I'm an assistant professor in the Civil and Environmental Engineering Department at the University of Arkansas. This is what we'll talk about today. We'll start with a brief background. Why is maintenance important? And then go over a summary of the maintenance techniques specific to Portland cement concrete. We'll then go over some common pavement distresses found in Portland cement concrete projects, and we'll try and match some of the techniques that we can use to the distresses that you see in the field. We'll then go over a brief explanation of the maintenance technique design from a materials perspective, and then a maintenance technique construction using both equipment and procedures. Now, this presentation is only 40 to 50 minutes long, so this will be a very broad overview. And I encourage you, if you have more topics that you would like to learn about in future Pavinars, please do go ahead, go to the website and submit topics, and we can dig deeper into any specific topics that may interest you. So we need to ask the question, why is maintenance important? And this graph is a very common graph shown in a lot of presentations, and it's from the FHWA, the Federal Highway Administration report, SA 98-079. And what we have here is we have the pavement condition on the y-axis versus the pavement life in years on the x-axis. And you can see here two alternatives that are offered. And this can be Portland cement concrete versus hot mix asphalt. They can be two different type of maintenance procedures for Portland cement concrete. And over time, these procedures will degrade, the pavement condition will degrade, and you will need to either reapply the maintenance or apply another kind of maintenance. But depending on what type of maintenance you decide to use, that will affect not only the initial cost, but also how long does that maintenance last. So sometimes it is worth investing a little more money up front if you have a longer lasting project or a longer lasting pavement long term. And as I mentioned, this is a very common plot comparing alternatives in pavement construction. Here is a summary of maintenance techniques for Portland cement concrete. And I divided this summary into three different categories. First, we have preservation. Second is functional. And third is structural. With preservation maintenance techniques, we are simply allowing the pavement to continue on as is. Something, for example, a seal or a joint has popped out, or debris has collected in the seal or joint, and we need to clear that out so that the pavement can continue to perform as it has in the past. And this can also be done by retrofitting edge drains. So if we do not have the proper edge drains, moisture and liquid can build up in the pavement structure, which is very bad for long-term performance. Transitioning from preservation to functional usually restores a smooth surface. So instead of doing preventative maintenance, like preservation, you're trying to restore something that had already occurred. And this can take place using partial depth repair, diamond grinding, or a thin overlay, whether it be PCC or AC. AC is short for asphalt concrete. And the third category of maintenance techniques is structural. And this is where we have a structural deficiency. So the pavement that was designed in the past is no longer able to carry the loads that are currently being applied. Therefore, you need to improve or enhance the pavement structure. One way to do this is to retrofit the load transfer, which is where you simply place dowel bars in between slabs, and this allows for the load to be transferred from one slab to the next. Another technique is called cross-stitching, and this has to do with longitudinal cracks. And when you have longitudinal cracks in Portland cement concrete pavements, you would hope that the aggregate interlock is able to transfer loads from one side of that crack to another. But if you're not able to do this, you can do something called cross-stitching, and that provides additional reinforcement and strength between those two sides of a longitudinal crack. And this can prevent the crack from either vertical or horizontal movement and widening. However, the crack must be in relatively good condition. You can't have a significantly deteriorated crack, or else the cross-stitching will not actually be very efficient. And we'll go into more detail on each one of these as well in future slides. Another structural technique is slab undersealing or stabilization. This is where you fill the voids that may occur underneath the slab. So underneath a PCC slab, you generally have some sort of base course or sub-base course. And if that base course or sub-base course moves away, whether it flows away or some sort of void is created, you can use slab undersealing or stabilization to fill that void. Now, you do not lift the slab using this technique. You simply fill voids that are created underneath the slab. And then finally, a very common structural technique is remove and replace. And if you're driving down an interstate, a Portland cement concrete interstate, sometimes you can see new small slabs that are between old slabs. And this often happens because deterioration often occurs around the joints of the Portland cement concrete pavement, and they simply remove and replace about 1 to 2 feet on each side of that old joint and put a new slab of concrete in there. And that's an example of removing and replacing. So some of the pavement distresses that can occur in Portland cement concrete. Well, you have your cracking, and there's multiple different types of cracking, including corner, durability, longitudinal, transverse, and map cracking. All of these have very different mechanisms, but at the end of the day, they crack the slab. You can also have joint deficiencies. In between the Portland cement concrete slabs, you do need to have a joint. That joint generally has some sort of seal between the slabs to allow for expansion and contraction and a little bit of movement. And sometimes that seal can get damaged. Once that seal gets damaged, deleterious material, dirt, dust, moisture can get into that joint and cause even more problems, such as spalling, which is where you have small chunks of the Portland cement concrete slabs that chip off, and it kind of looks like a pothole in a way. And then you can also have faulting, and this is where the slabs move up and down in relation to each other, and this creates a very uneven surface, which is not good for a smooth driving surface that you want. There are also many different types of surface defects, such as scaling, pop-outs, and polished aggregates. Again, various reasons for these different defects, but at the end of the day, they are distresses that need to be fixed on occasion. And then finally, there's a couple of miscellaneous pavement distresses, such as blow-ups, which is where the concrete slabs want to expand so much to the point where they can no longer expand in a horizontal direction, so they literally blow up and lift up, and that causes the slabs to lift up, and it's called a blow-up. And also there's water bleeding and or pumping. If the slabs are moving up and down in relation to each other, sometimes water or material in the base and the sub-base can actually come up to the top of the pavement. Now there's a very good tool out there if you're interested. The Federal Highway Administration has put out the Distress Identification Manual. And if you simply Google the term Distress Identification Manual, you will be able to find this and download it in PDF format. And this does a very nice job of going over what these distresses look like and then how to quantify the severity of them. So we've talked a little bit about the different types of maintenance techniques and the different types of distresses. And now we're going to move more into the techniques, go into a little more details about each one. So if there's any question now, I encourage you to raise your hand using the hand with the green arrow, and then also please type the question into the chat box. Okay, so there's no questions, so I'll move along. Again, if you do have a question during the presentation, please feel free to raise your electronic hand at any time, and we can take questions as we go along as well. Now we'll talk a little bit about matching techniques to distresses. So before I was talking about different types of maintenance techniques, the preservation, functional, and structural types of maintenance techniques, and now we'll kind of go into a little more detail into each one of those and what they are and what sort of distresses can be associated with them. For example, the first one, the resealing of joints and cracks, that's an example of preservation. This can happen because there is seal damage. So the seals that are placed in between the two concrete slabs can degrade, or they can lift out, and those seals are no longer tight, which means that dirt and material can get down into those, and then the concrete slabs cannot expand and contract due to thermal effects, and they also are not able to move up and down, which there is very small movements, but some sort of seal damage can restrict even those small movements. And what can happen if you have those is the water bleeding and the pumping. So once those seals get damaged, water can go in and can come back out of those seals. And also material from the base and subbase can actually start moving up through those joints and cracks and cause more significant damage. By resealing your joints and cracks, you may slow the water bleeding and the pumping, but you're actually not solving the fundamental problem, which we'll go over in the next slide. So resealing joints and cracks can reduce water bleeding and pumping, but it will not actually eliminate the fundamental problems of them. The next type of technique is retrofitting the edge drains. Many pavements have edge drains, which moves the moisture out of the pavement layers to the sides and then directs that moisture to a point where you have proper drainage. And by retrofitting these edge drains, you can increase your drainage capacity. Often pavements are not designed with enough, well, I shouldn't say often, but on occasion pavements are not designed with enough drainage capacity. And if the pipes are too small in diameter, if the pipes are too small in diameter, or if they don't have enough holes punched into them, then the water will continue to stay in the pavement layer and the drains are not doing their job. A very important preservation technique for Portland cement concrete pavements is making sure those drains, those edge drains, are not clogged. Obviously, when you're talking about water moving through these pavement layers, a lot of silt and a lot of fines can accumulate, and these can actually clog, which causes significant problems with future drainage. So part of any highway agency's preservation technique should include making sure that the edge drains are not clogged. And in fact, here in the state of Arkansas, there's actually 2 crews that work for the Arkansas State Highway Transportation Department, and their only job is to transverse the state roads and make sure that all the edge drains are not clogged, and if they are clogged, to unclog them. Some times that we would use partial depth repair, whenever you have minor cracking, obviously the crack or the punch out in this picture on the left is a pretty significant distress. But if you have simple minor cracking, sometimes you can solve that cracking with a partial depth repair. Also, if you have spalling at the joints or scaling, pop-outs, or polished aggregates along the project, partial depth repairs are sometimes a good solution for that. Things like scaling and pop-outs sometimes occur if there's segregation in the mix, which means that there's a very small area of your project that has either too many larger size aggregates, maybe improper cement content. If there's some sort of segregation issue with that section, sometimes a partial depth repair will be adequate in order to solve that. Another type of technique, diamond grinding, is well used when you have faulting. Again, faulting is when the slabs move vertically against each other, so if one slab raises maybe a ½ an inch or so, you will get a fault. And if that does fault up to a ½ an inch and then maintains that elevation, by diamond grinding you can restore a smooth surface. Now if the faulting goes back and forth, diamond grinding will not help as much with that, because you want to be able to grind down to a level where you know it will not change from. Diamond grinding is also a technique in order to restore surface friction. So if you have polished aggregate along your project, you can simply diamond grind along those short sections and restore some of that surface friction. And moving on to some more advanced techniques, the thin overlays. Again, these overlays can be either Portland cement concrete, which is often called white topping, or hot mix asphalt. These thin overlays can alleviate minor cracking. Again, this is cracking that you do not want. If If it does not become more severe over time, thin overlays can aid with the minor cracking. These thin overlays can also be placed over scaling, pop-outs, and polished aggregates. This will allow to restore that surface friction to create a level surface by using an overlay. A very common thing you see, in fact, if you ever drive on Highway 412 in eastern Oklahoma, you'll see that they had to retrofit load transfer, and this will prevent faulting or future faulting. This is a very distinct technique because every single joint you will see 3 narrow bands of concrete that has been replaced, and that's because you need to actually take material out at each joint, place a dowel bar down into there, and refill that small slot with new material. So it's a very distinct technique that's pretty easy to see. As I mentioned, cross-stitching will alleviate future deterioration of longitudinal minor cracks. So if you just have some small longitudinal cracks, you can use the cross-stitching in order to prevent those cracks from becoming more severe. You can use slab undersealing and stabilization to help prevent future worse cracking. If there's a void underneath the pavement and you have a crack, often that can deteriorate very quickly as that slab or that piece of slab wants to go down into that void. So by undersealing, you can make sure it has at least a level surface to sit on. And also slab undersealing can prevent future water bleeding and or pumping, because if there is a void, that slab may want to move up and down. And when the slab moves up and down, that's what creates the mechanisms in order to force that water and force those fines up to the surface of the pavement through the longitude or through the transverse joints. And then finally, removing and replacing. This takes care of major cracking and also blow-ups. So if you have major cracking or blow-ups, sometimes the best option is to simply remove the material and replace it. And that will be the best way to match your technique to your distress. So we've talked about the distresses and techniques. Now we're going to move a little into the materials. Does anyone have any questions? Yes, Alex, thank you. So the question from Alex is, when would rubbleizing the concrete be appropriate? Well, that's a very good question. And this presentation, I wanted to focus kind of on the maintenance principles for Portland cement concrete, which in my mind implies you have an existing Portland cement concrete pavement, and at the end of the day, you would still like to have a Portland cement concrete pavement in place. I think that rubbleizing concrete is appropriate for 2 reasons. One, the entire project is in pretty poor condition, so there's a lot of cracking, a lot of these distresses that we've been talking about, and the agency or the contractor feels that it's really not worth replacing all of that. So they may rubbleize it and then put either a ultra-thin PCC layer, or what's called white topping, or like an asphalt concrete layer on top, and overlay. And that's those two are often popular decisions because you can actually increase your structural capacity a little bit. But rubbleizing, I think, tends to be kind of when the road is either too far gone or you feel you need increased capacity and you have enough clearance going underneath bridges and other geometric considerations in order to actually put some sort of overlay on top of that. Are there any other questions? Okay, good. Thanks, Alex. So now we're moving more into the materials. So again, thinking back to that summary of maintenance techniques where we had the preservation, functional, and structural maintenance techniques. We're going to move through those and you'll kind of see some examples and some pictures of each one as we go along. So when you need to reseal your joint or crack, there's a couple different sealants you can use. There's your neoprene rubber, your silicone, or your polyurethane. Some of those are synthetic. I'm not, off the top of my head, I'm not aware of anyone using natural rubber, but I guess it could be a possibility. And you can also use hot pour rubber asphalt. So when you've cleaned out your joint or your crack, you can place these materials back into there, and that will prevent new material from getting in to those cracks or joints, and will also continue providing that smooth pavement surface. Now there's a term that you may see if you look into this more, and that's called tooling. And tooling simply means that you need to force the material against the sides of the joint or the crack for proper adhesion. So for example, maybe a silicone would be a type of sealant where you need this type of tooling because it won't naturally force itself against the side of those cracks and adhere. Whereas hot pour rubber asphalt is a self-leveling type sealant. And that when you pour it into the crack, it will naturally flow and push itself to the sides of that crack and adhere. And there's pros and cons with tooling versus non-tooling sealants, but that's just something to be aware of when you're starting to think about your joints and cracks and how to reseal those. The next type is partial depth repair, and you can see this picture on the right here. They did not take away the entire Portland cement slab. They simply just took away a small finite depth portion of that slab in order to fix some sort of distress. And after you take the material out, you need to fill it back up with something, and you'll need to use either a cementitious material, a polymer-based material, or a bituminous material. So a cementitious material can be conventional Portland cement concrete, very similar to what was there in the first place, or you could also have gypsum-based or magnesium phosphate concentrate materials. And again, these all have pros and cons. I'm not going to go into the details, but there are options when you're thinking of cementitious materials and what you want to put back into that pavement surface. Some of these materials are polymer-based, whether they be epoxy, methyl, metacrylic, polyester styrene, polyurethane, or polymer resins. These kind of have the advantage of being able to literally squeeze out onto the pavement surface in a way very similar to like, Elmer's glue would be a decent analogy, and that would kind of self-level and fill in that surface. You may want some aggregate though to provide some structure. The problem with these though is they're usually very, very expensive. They may be a little more difficult to work with. They're certainly not as common. So those are all things to take into consideration as well. And then finally, you can use a bituminous-based partial depth repair, whether you use asphalt cement or emulsion as the binding agent. You do need some sort of aggregate. And I'm sure we've all driven down roads where it's a Portland cement concrete road, and then there's some sort of asphalt patch along that project. And that could be a partial depth repair that they chose to use in that way. The next type of treatment we'll talk about is thin overlays. A thin overlay is where you have an existing Portland cement concrete road. Generally, they're not rubbleized, but they do have a significant amount of distresses where other options aren't quite as attractive. The thin overlay can either be Portland cement concrete or asphalt concrete, and there's some terms that they use to differentiate what type they are. You can have bonded versus unbonded. And generally when a concrete overlay is placed on a concrete structure, or excuse me, a concrete overlay is placed on an existing concrete pavement, that's called a bonded overlay. But if you have some sort of asphalt concrete interlayer, so you have an existing concrete road, you place a small thin lift of asphalt concrete, and then you have Portland cement concrete on top of that again, you have what's called unbonded. Some rules of thumb when you're doing thin overlays. First, you would like a maximum aggregate size of 1/3 of the overlay thickness. You don't want aggregates dominating your thickness of the overlay. So if you have like a particularly large aggregate, you want to make sure that you can stack at least 3 of those on top of each other, and then you get the full benefits of the mixture design that you performed. And also very critical is the thermal coefficients of the layers must match. So pavements do expand and contract when the temperature changes, and you want to make sure that these layers that you're putting together expand and contract the same distances, the same amount. Because if they expand and contract to different sizes, then there will be problems with that interface area. So perhaps the bottom will expand a little more than the top, and you'll have uneven joints, and that's a very bad quality for pavements. So you want to make sure that they shrink and expand at the same rate. Here's a picture of the Retrofit load transfer. The machine has already cut the little troughs in, and then you can see the dowel bars can be placed down into those troughs. The dowel bars are typically epoxy coated, and once you put those dowel bars down in there, you need to either put backfill or what's called repair material into those troughs in order to make a smooth, level surface. And you really want little to no shrinkage with that backfill material. If it shrinks too much, it could come out very quickly, and you could have uneven roughnesses along there. Similar to the overlays, you want similar thermal compatibility, so you want the material to expand and contract the same amount as the pavement itself. And then of course you want good bond strength. You don't want to put a material down into there that will come out very quickly or have some sort of problems along those lines. And finally, the materials in general are very similar to the backfill materials, or the backfill materials for a retrofit load transfer are very similar to the partial depth repair materials. So you can have the cementitious materials, you can have the polymer-based materials, or you can use bituminous materials as well. When you're looking at slab undersealing or stabilization, you need to insert flowable material under the concrete slab, so you'll need some sort of pressure to do that. And by filling those voids underneath the slab, you reduce future deflections of the concrete slab. And really the most important thing about these materials is they must flow. And that seems kind of obvious, but when you're filling that space in underneath the slab, you want to make sure that the material can flow into all the nooks and crannies, all the small corners around there, so that there are no voids remaining. It's very similar to backfilling a pipe trench. Usually pipe trenches, you place the pipe down there, and there may be space underneath that pipe and the existing soil material, so you want to make sure that your grout can flow underneath there. And you can have cement or fly ash based grouts. You can also have asphalt-based grouts or polyurethane-based grouts. So all of these are materials that can flow and fill up all the surface underneath there. And finally, the remove and replace. Generally, you have conventional Portland cement concrete. When you remove and replace, you can simply take out the old material all the way down to the the base course, and then put new Portland cement concrete. You can also use kind of specialized concrete. So for example, high strength concrete, which has a lower water cement ratio, or it may have a chemical accelerator so that it sets and gains strength a little faster. But you want to be careful when you start looking into those options, because they can increase costs, and you can also require special handling. So it may involve getting a crew out there, a trained crew with that new material. So we're moving on to the last section, which is the construction section. I'll take any questions now, if we have any. Okay, there doesn't seem to be any questions. Again, if you do have questions, please feel free to raise your hand during the presentation, and we can go from there. So talking about the construction of these, when you're resealing joints and cracks, it's very important that you make sure the concrete is at least partially cured, and approximately 7 days is a good rule of thumb for this. You don't want to make one of these joints or make one of these reservoirs with concrete that is either not cured enough or, on the other hand, cured too much. If you wait too long, other cracks can form, or it becomes very hard, which can, when you put that saw in there, you can cause additional damage. So you want to look for about a 7-day cure time. The joints that you make are approximately a 1/2 inch wide to 2.5 inches deep, and those are approximations. You can see in this figure they have some slightly different numbers, but that gives you the ballpark. And the width to depth ratio, so how wide the joint is to how deep it is dependent on what material you use. If you use a silicone-based material, you can get away with a 2-to-1 ratio. But if you have a hot-poured material like an asphalt cement or some sort of tar-based sealant, it's usually a 1-to-1 ratio. It's important to think about what type of joint or crack you're sealing. A transverse versus longitudinal joint, they may have different mechanisms on either future deterioration or things that could happen in the future. So you want to make sure that you identify exactly what type of joint you have, what kind of distresses are either in place or future distresses, and then you can make a more informed decision about your sealing type and sealing mechanisms. After you have cut your reservoir, you want to either sandblast or water blast or air blast and make sure that that's very cleaned out. You don't want any grit or leftover material on the sides of those joints, reservoirs, because then the sealant could adhere to that grit and then come right out of the joint. You want the sealant to adhere to the concrete itself and not to any dirt or grit that happens to be on the side. You also don't want any moisture, slosh, or saw slurry in there. When you're cutting these joints, you will get a little bit of saw slurry. It's a wet process, so you want to make sure you flush all that out as well. And then finally, the reason that you want the joint to go a little deeper is because often you are forcing a crack to form there, especially on, say, if you're putting a joint in on a full depth patch and you need a joint in the middle of that. You want to make sure that all cracks start forming at that location. Often you don't want to fill that entire joint up, however, with sealant, whether it be due to cost or material handling. There's various reasons. So sometimes you'll see a backer rod being put into the joint, and that allows something for the sealant to sit on top of, but still have a deep joint to get that crack forming. Some of the important things to think about when doing retrofit edge drains. Again, these edge drains are meant to direct the water away from the pavement layers into areas that have better drainage capabilities. Oh, Philip, did you have a question? Well, it actually seems that Philip has left the room, so I hope that we didn't lose him inadvertently. If he comes back on, though, we can see what his question was. So when you're retrofitting edge drains, it's important to remember that larger diameter pipes clog less than smaller pipes. So if you have an existing road that may need a retrofitted edge drain and it has these small pipes, especially if it's had problems in the past with clogging, it might be beneficial to increase that diameter of the pipe and you'll get less clogging. You'll also need deep trenches and treated permeable bases. So when you're thinking about existing Portland cement concrete pavement structures, some of these things may not be options. Like you obviously can't change the base course that's underneath there. Whereas if you are doing a retrofit, it may be an option to dig slightly deeper trenches. So those are a couple things to think about when you're going back and trying to solve some of the problems behind the clogging and maybe some of the possible solutions that you have. When thinking about partial depth repair, these are the steps that you take in order to perform a partial depth repair. First, you need to select your repair dimensions. So in this diagram here, there's some sort of spalling going on at the joint, and you want to determine, well, how much area do we actually need to take out and then place back in. So you want to make sure your repair dimensions are all lined up. You then need to remove the concrete and clean. Much like joints, you want to get as much of that dust and grime, any sort of saw slurry out of the area that you're going to put the new patch on, so it's a nice clean surface for the patch to adhere to. Often these patches occur along a joint, so if you are putting a patch in along a joint, you want to make sure that you prepare the joint properly and that's all lined up before putting that patch in. You don't want that patch, if it is right next to a joint, you don't want that patch touching the other slab. You'll actually need a little bit of space there so you can put your new joint in, and the slabs can move and expand and contract as necessary. Once you've done all that, you have some sort of bonding agent application, so it's some sort of gluing material that you put along the patch, and then you can place the patching material in there and finish the surface, and then you simply let it cure. And this will allow you to get a nice smooth patch that hopefully will not come up quickly over time and will maintain the pavement surface and structure that you need. When you're diamond grinding, kind of taking a step back, you want to remove any surface irregularities, restore your smooth riding surface. You may want to increase surface friction or even reduce noise. And generally these diamond grinds are only 0.1 to 0.25 inches in depth. So you're not taking much material off that surface. And you can see the picture in the lower right hand is actually a picture of the diamond grinding machine. And where it is ground already, which is that slightly darker gray area, it's not very deep compared to the lighter area. The spacing of the blades, there are many blades lined up along there, is based on your aggregate hardness. So if you have a very hard aggregate, such as a granite, you'll probably need a little closer spacing. Whereas if you have a softer aggregate, such as a limestone, you'll need a little bit wider spacing. And that's simply because if you use the wider spacing with the harder aggregate, sometimes you can actually get little ridges that form. And if those ridges are formed and then traffic gets let back onto there, they can start breaking down, and then you'll have material on your pavement surface that can come up and hit windshields, and it won't look very nice. And then you'll have kind of uncontrolled breakage of those little ridges as well. So when we're talking about spacing, closer versus wider spacing, typically we're looking at a window of 50 to 60 blades per foot of width. So these are very, very small or very, very narrow blades, and there's 50 to 60 of them per foot. After the grinding has occurred, you will want some sort of wet vacuum to pick up the slurry that's left behind. And a lot of machines come with a wet vacuum already on board, but if you do have an operation that doesn't have those, you'll probably want to follow up with a wet vacuum so you can get that material off the surface and have a clean surface for future traffic. When you're talking about thin overlays, the first thing that you want to do is you want to texture the existing pavement, and that will give it a nice coarse, a nice textured surface to adhere to. And you can do this by either shot blasting, sandblasting, or cold milling. And there's a picture of a cold milling machine there on the bottom. And the typical texture readings, when you're thinking of like your IRI, is a 0.05 to 0.095. That's kind of the texture that you're shooting for in order to get that roughness so you get a good adhesion. You do want to go ahead and replace any existing damaged concrete. So if you have like, an area of significant damage, whether it be cracking or spalling or something along those lines, you can take small sections of concrete out and replace it with new sections so you have a good solid, a good consistent foundation to place your overlay on top of. You also want to remove any asphalt patches and replace those with Portland cement concrete. After you've textured and replaced any damaged concrete, you do want to clean the surface so you have a nice clean surface to adhere to, and then you place your overlay. When you are doing your retrofit load transfer, you first need to cut your slots for these dowel bars, and the machine is there on the right. And you want 12-inch spacing, or 1 foot spacing center to center between these dowel bars. To prepare the slots, you want to remove the material after the cutting, and you want to clean them out. This is a pretty common theme whenever you're doing these type of maintenances on Portland cement concrete. You want to make sure you have a clean surface before putting any new material down there. And that will ensure good bonding between the material you're putting in and the existing pavement layer. You then want to caulk the areas. Because these are being put at joints, you want to make sure that no fill material enters that joint, and that's what the caulking does. After doing that, you simply place the dowels and then you backfill your slots. Now when you're doing cross-stitching, here on the right you can see an example of a longitudinal crack. You generally want to drill holes at an angle. So going down into the pavement at say like a 30 to 45 degree angle. And you want to intersect your longitudinal cracks and joint. So as you have these cracks moving along the surface, you actually want to insert a hole at an angle that goes from one side of the cracked surface to the other side. And you want that hole to go down to about the mid-depth of the slab. You want to remove all the dust with compressed air, and then you simply inject epoxy into that hole. So that epoxy will go from one side of the crack to the other side of the crack at an angle. Then you simply insert your tie bars and then remove any excess epoxy. And this will allow the tie bars to sit in that epoxy. As the epoxy cures, it will gain strength, and then you'll have a nice solid transfer between the two sides of the longitudinal crack. If you're performing slab undersealing or stabilization, the first step is to drill about a 1 1/4 to 2 inch diameter hole through the concrete slab. And the pressure on this drill should be less than 200 pounds force, and that's to avoid slab damage. You don't want so much force where you're actually pushing the slab down into that void, which can create significant cracking problems. You just want to make sure you have enough pressure on that drill in order to get a sample out of there. You then get a group packer, and the group packer injects material into the hole. And as you're injecting material, you want to make sure to monitor the pumping time and the slab pressure. You do not want the pressure to start building underneath that slab, because that can actually put forces on the bottom of the slab pushing up. And also you don't want any sort of slab lift. If you put too much grouting underneath there, you may actually start lifting the slab up, and then you're essentially creating faulting, which is another distress that you don't want to have. It is very important to remember, when you are undersealing or stabilizing, you are filling your voids, you're not lifting the slab up. And this fill doesn't increase your structural capacity either. It's a replacement of material that has gone away and created that void. So you're not increasing structural capacity, you're simply putting the structural capacity back to what it was before. When you're talking about removing and replacing, again, you first want to select your repair dimensions and take the concrete out. For a full depth remove and replace, you do need to repair the area, including preparing either the base or the sub-base and subgrade materials. Often there are mechanisms occurring underneath your concrete slab in the base, sub-base, or subgrade, and you want to make sure you solve those problems before putting new concrete in there. So you have an opportunity to do that when you remove the existing concrete. You want to make sure to put the load transfer devices in, and the schematic shown here on this slide is an example of that dowel bars being placed in there. And this will allow load transfer between the existing slab and then the slab that you're putting in. Once that's been set up, you simply place the concrete and finish it, and you let it cure. If necessary, you can saw joints into the pavement, but you will definitely need to make sure you seal the joints between the existing slab and the new slab, and any new cuts that you have in that pavement. You want to make sure you do your good joint formation and you seal that so material doesn't enter into there and create future problems. So today we've gone over some distresses and techniques in Portland cement concrete. We've gone over some of the materials involved with those techniques and also some of the construction. So if there are any questions, please feel free to raise your hand. And if there are questions, please do raise your hand, but I'm actually going to go over the final slide and then come back to this slide. As we're getting near the end of the presentation, I don't want to hold anyone over. So as a wrap up, I have all of your email addresses. I will email you the PDH certificate. You can re-watch Pavinars through the website. So if you go onto the website, pavinars.uark.edu, you can re-watch any of these Pavinars. And please, if you have any topics, feel free to submit them through the website. And our next Pavinar will be Tuesday, November 1st, and it will be an overview of warm mixed asphalt. So I thank everyone for participating, and I will take any questions now. If there are any questions, please raise your hand. And if not, I do believe that that is the end. Again, I thank everyone for coming, and I invite you to participate next month as well. Thank you very much, and have a great afternoon.